Hey guys, I hope you're all doing good. In the last video, we looked at some basic geometry manipulation using Converge Studio. I was primarily going over the basic geometric entities like vertices, edges, and triangles. And we looked at how you can select them and then how you can delete the triangles and then how you can create triangles using the delete operation and the loft operation. So in this video, I wanted to go over the different types of surface errors that can occur, and we are going to look at this by first taking up a realistic geometry. So here you are looking at a solid piston. People would use something like this to do a conjugate heat transfer analysis. It's very important that the surface looks clean and does not have any of the problems. So here I've loaded a STL file. STL is a popular file format that stores the geometry as triangles. So when I loaded the geometry inside Converge Studio, I see all these different colors, right? What do those mean? Anytime the geometry has problems, Studio is going to show that to us. So what we need to do is spend some time in learning what these errors mean, and we need to come up with strategies to tackle it. So the first thing I'm going to do is I have my diagnosis doc open here. As I mentioned in the last video, if you do not see it, go to the view menu and then you should see diagnosis doc. Alternatively, you can do Control D, that's the shortcut. So let's run the diagnosis, and you can see that there are several intersection errors, non-manifold problems, and open edges. Okay, and the first thing that we need to do is understand what these errors mean and then come up with strategies on how to tackle them. All right. We won't be working on this geometry yet. This would be in a harder geometry to clean up. So first we are going to move forward to a simpler geometry. We are going to understand what those errors mean. By keeping the geometry simple, we can focus on the errors. Currently there are so many errors that it's making it difficult for us to isolate the problems. So what I'm going to do is I'm going to create a new file and I'm going to create a box. And I'm doing this by going to the geometry doc, clicking on create, shape, box, use the default parameters and click on create. Now what I'm going to do is I'm going to select the top faces. First I change my entity type by pressing 3. So that's going to enable triangle selection. I'm selecting these two triangles. I'm pressing Ctrl H. That's going to hide the top face. I'm not deleting it, I'm just hiding it. So what I'm going to do next is create intersecting triangles, and the way I'm planning to do that is I'm going to create triangle, and I'm going to create triangle from 3 vertices, and the vertices that I'm going to select are this guy, and this guy. Right, so I'm creating that face there, and similarly I'm going to select this corner vertex, this one, and this one. Okay, so let's take a look at the geometry a bit closer. You can see that I have a cube where I have these two triangles that are just passing through each other. So this is my cube. It looks perfectly fine from the outside, but if I just hide a couple of faces, again for hiding I'm using the shortcut Ctrl H. You can always do a right click and then click on hide selection. All right, so there are several issues going on here. So first you can see that you have these yellow lines. So what do those mean? Yellow lines indicate open edges. So a valid surface is a surface where a triangle, where each and every edge in a triangle is shared by 2 triangles. So to demonstrate that, let's create another shape, and we are going to create another cube, but this time I'm just going to offset the cube by 0.05 so that I create it somewhere else. If you take a look at a triangle here, then what you can do is if I rotate around the triangle, you can see that any given edge in this triangle is shared by 2 triangles. This is the right connectivity that we need. If an edge, for example, let's take this particular edge, okay, and I'm just going to use any type, this particular edge, it's being shared by this triangle and this triangle. Okay, so now if I delete one of those triangles, I'm left with an open edge, right? Because now these 3 edges are being shared by only one triangle. This edge is shared by this triangle, this edge is shared by this triangle, and finally this edge is shared only by this triangle. Okay, and that is why we are getting this open edge loop. All right, similarly the other extreme is if you have a single edge that is being shared by more than two triangles, then that edge is called as a non-manifold edge. So non-manifold edge has this purple color here. So for example, if I select this edge, right, you can see that this particular edge is being shared by three triangles. And to make this more evident, I'm going to go to triangle selection mode, select the first triangle, the second triangle, and the third triangle, right click, and I'm going to use isolate selection, or alternatively I can use Ctrl L, and this is just going to isolate the triangles that we clicked on. Okay, this is kind of opposite to the height selection option. So here you can see that this particular edge, which is being colored purple, is shared by more than two triangles, and this is called as a non-manifold edge. Now non-manifold edges are not okay, except if you're doing conjugate heat transfer simulations using Converge CFD. All right, in general we consider this as invalid triangles. So I'm displaying my geometry again, and this time let's actually hide the faces one more time. I'm using the Ctrl H shortcut there, and we have looked at open edges and we have looked at non-manifold edge. The final thing that we want to take a look at is intersections. So intersections are fairly easy. So let me select the two triangles, and I'm going to press Ctrl L. That's going to isolate the selection. So here you can see that two triangles are just passing through each other. Now why does this happen? Most of the surface errors come from the CAD part. So when you create a geometry in CAD, so for example I have this drawing here of a piston part which looks perfectly fine, okay, but when I'm exporting this model as a STL file, then I'm relying upon the software's ability to convert the accurate 3D geometry into a triangulated file. If the triangulation is not good, then there is going to be a lot of errors in the final surface. So what people do is they either have powerful surface measures that can convert a native CAD file into STL files, but the trend in the industry now is all of the major CFD players have incorporated the ability to read in native CAD files. So you can read the CAD files in the CFD tool itself, and it's going to create a perfect triangulated mesh which will have fewer problems. Okay, all right, so that being said, let's go back to Converge Studio. So in this particular case, what I'm going to do is to fix the errors, I'm just going to delete the intersecting triangles. So to do that, I'm going to go to triangle selection mode, and then what I'm going to do is I'm going to select the two triangles by first going to triangle selection option, and then I'm going to go to repair, delete, and I'm just going to click apply, and I'm going to select my triangles again and then just delete it. So now if I redisplay the geometry and do find, you will see that I don't have a lot of errors, but let me just undo this step one more time and then run the diagnosis again. I just wanted to show you that before I delete the triangles I had 4 intersections and 5 open edges. So now if I can just repeat the process one more time, I'm just selecting the problematic triangles and then I'm just hitting D, that's the shortcut key that I can use to delete, and then if I do find, you can see that most of the problems are gone and I still have open edges. What I can do is, when I look at the geometry, I don't see any open edges, right? And if I do redisplay, I don't see any open edges. So what I can do is I can click on open edges and click on show. And this is going to show me where the problems are. So let's redisplay. And if I rotate the geometry, you can see that here I have this open edge. We deleted a triangle, if you remember. So I need to fix this. So how can I fix this? I can fix this using a couple of ways. So first I can just go to create triangle, and then I can just select the 3 vertices, hit apply, and if I do find again, that's going to solve the open edge problem. We have a new problem. We'll take a look at this later. Alternatively, what you can do is, if I undo, basically I'm deleting the triangle again, I can go to repair, patch, and then I can just patch this. So what the patch command does is it basically selects a list of edges and then creates triangles with it. So what I can do here is I can basically select the free edge loop option, and what I'm going to do here is I can just click on one single edge, and then Converge Studio is just going to look at the neighbors. If that's an open edge, it's going to detect that, and then it's going to try and patch the surface automatically. The other thing that you can do is when you have the free edge loop, you can go ahead and select open edge from the selection type, so that you know exactly what you're selecting, you know exactly what the open edge is that you're patching, right? And then if we hit diagnosis, you can see that the problem is solved. So I'm going to undo this one more time, and I'm going to go back to create triangle, and I'm just going to manually select the 3 vertices. Click apply and run diagnosis one more time. So when I did this, you see that I have 4 normal orientation errors. So let us display the normal by clicking on this button. So you can see what the problem is. All the faces have normals in one direction. Basically, it's pointing outside the box. So let me just hide these 2 faces. And if I just look inside, you can see that in the top face, one triangle has a normal pointing inside and one triangle has normal pointing outside. So in a closed surface, all the triangles should have normals pointing in the same direction, right? That is one of the requirements, right? If you have to do CFD, and that is why we are seeing this particular problem. So the way we can actually fix this is we can actually go to transform, normal, and then I'm going to select the triangle whose normal I want flipped. Okay, so in this case I'm selecting this triangle, and then if I hit apply, you can see that its normal got flipped, and so did the normals for the other triangles as well. Now they are all consistently pointing in the same direction. If I click on this again, and if I click apply, the normal is getting pointed the other side. So let's run diagnosis. You can see that there's no normal orientation. If I flip the normal again, it's going to point inside. If you click on find, again no errors. So it really doesn't matter in which direction your normals are pointing, at least at this point, because we are just playing with boxes. We still haven't talked about the concept of the fluid domain. So for now, just remember that you should have consistent normal direction, especially if it is a closed geometry. When I say a closed geometry, your cube is self-contained, it's completely closed. Okay, so in a given cube, for example, in this case, you can see that the first cube has normals pointing outwards and the second cube has normals pointing inwards. And if you hit find, there are no errors. That's fine, because we just want to make sure that each closed surface has normals in a consistent direction. Okay, all right. So let's learn a few more geometric tools. I'm going to create a new file, and what we are going to do is we are going to create a sphere this time. So create shape. We are going to select a sphere and just click on create. All right, so we have a nice looking sphere here. So we'll be using some of the tools that we learned so far. So once I have my sphere, I'm making sure that I'm selecting triangles. I'm going to use the box select tool, select a few triangles, and if I press the D key in my keyboard, it's going to delete those triangles. All right, so now what we are going to do is we are going to basically fix this particular problem. All right, so how are we going to do that? So the first thing that I'm going to try is going to repair patch, and I'm just going to select by open edge, click on this particular edge. You can see that nothing is happening, and that is because I'm currently using the box select mode. If I go to cursor pick mode, and then if I select this, you can see that the loop has been selected, and if I click apply, it's going to patch it. Now remember, when you patch something this big, you are not retaining the curvature. So if I put the model in a different view, you can see that the curvature has been lost. The curvature information has been lost. So you need to make sure that when you're using the patch tool, you are not patching really large holes. If the hole sizes are small, then the curvature loss is also going to be minimal. Okay, so keep in mind. But for now we are just practicing the tools that we are learning, so this should be fine. So I'm going to hit Ctrl Z to undo this. Okay, so the next thing I want you to learn is under the repair option there is something called a stitch. So what stitch does is it allows me to stitch two vertices. I have a from vertex and I have a to vertex. Okay, so make sure that when you're stitching vertices your entity type is vertex. Okay, and if I click apply, it's just going to stitch the vertices. So ideally what I can do is I can just keep on stitching this and this, and you can also stitch using the shortcut key S. Okay, and if I can just stitch these to this, and I can just keep doing this process, right? I can keep doing this process to basically close this entire hole. Alright, so the stitch sometimes comes in handy, but again now I'm just going to undo this. So the next thing that I'm going to do is I'm going to draw another shape here. So go to create shape. So what I'm going to do is I'm going to draw a box that connects to my sphere. We are not shooting for a particular geometry. I'm just trying to take a really long cube or a box, and I'm planning to fit that to my sphere. So I'm going to create a box, and what I'm going to do is I'm going to eyeball the geometry, right? So the thing that I need to know is how big is my sphere. So I go to options and I click on geometry bounding box. So I know that my sphere is roughly 0.02 meters, and if I zoom out you can see that the coordinate system is actually there in the center of the sphere. So now I know that that's the origin. So what I'm going to do is I'm going to create a box. I'm going to say that the center of the box is 0.5 meters and 0 and 0. So I'm expecting that the center is going to be somewhere here, and the length of the box in the Y direction. Okay, the Y direction, I want the length of my box to be approximately 1 meter. All right, and the size of the box in the other directions are 0.01 and 0.01. So let me just click on create. You can see that I have something like this. So I think I drew my box a bit bigger, so I'm going to just do Ctrl Z, and this time I'm just going to say that the box dimension is 0.05 and the length of the box is 0.1. Okay, so now if I click on create, that looks more reasonable. So you can see that this is a very difficult connectivity problem, and what we are going to do is we are going to use the tools that we have learned so far to make this geometry valid. So if I click on find, you can see that there are 122 intersections and 63 open edges. So the first thing I'm going to do is I'm going to just patch this guy. So I'm going to go to repair, patch, select this open edge loop, click apply. And now if I do find again, you can see that I don't have open edges anymore. I still have intersections and normal orientation. So let's first fix normal orientation. Let's go to transform normal, select a particular triangle, click apply, and then I'm basically flipping the normal. And what you can do is you can just have the normals turned on when you're flipping it, but after some time you get used to it, so you don't have to always look at it. So now you can see that normal orientation error is gone. I still have 123 intersections. So how do I fix this? I mean, how can I possibly fix this? I mean, this is a much harder problem, right? Ideally you want to do something like a Boolean operation. Those are slightly advanced techniques which we don't want to worry about right now. So initially we are just concerned about fixing these errors as best as we can without using automated tools. Alright, so when I look at this geometry, you can see that there is a set of triangles with which the box actually intersects. So what I can do is I can just delete some of these triangles, and then I can connect my box to the sphere. So let's do it in a couple of ways. So first is let me create two separate boundaries. So I'm going to go to boundary, and I'm going to add the cube to a separate boundary, or cube or a box. And the way I'm doing that is, I clicked on this plus button that added a new boundary. I'll just right click on it and then give it a name. I'm just going to call it box. And then from the type, I'm just going to use the method called a surface. This is a new method that we're using, but what it basically does is it selects objects that are self-contained. So if you remember the previous example, we drew two surfaces, right? We drew two cubes. Those are separate entities that are not connected with each other. So in this case, this longer box is not connected to the sphere. So I can just select the box by using the surface option, add it to the box boundary. I can create one more boundary, and I can actually give the name to this boundary right here. I'm just going to call it sphere. Select the second guy and then put it over there. So my strategy is, again, I don't want to be super accurate here. My expectation is to just clean up the surface. I'm not looking at cleaning this up as accurate as possible. I just want a clean surface. In other words, I just want this surface intersections to go away. So what we have to do is we have to somehow, if I hide the box, you can basically see that Converge Studio creates this nice boundary, right? I want all the triangles inside this particular boundary to be deleted, because once that is deleted, then I can use some kind of a patch command to solve the problem. All right, so let's think how we are going to delete this. Now, obviously, the easiest thing we can do is go to repair, delete, and we can try to select one triangle at a time. That might be an option, but what we are going to do now is we are going to create something called as a boundary fence. So what does that mean? So the idea is quite simple. It's just like building a fence. So we are basically going to create an area that is closed, and anything that is inside that area, we are going to delete it. So it's much easier to understand this in action. So let me go to boundary, and then I click on fence, and I'm going to be selecting two vertices. Make sure that between two vertices option is selected, and then I'm going to select vertex number 1, vertex number 2, and then click on mark fence. You can see that there is a small color change. It's hard to notice, but you can now see that you have this white line running from this point to another point. So I select the same thing here and this point. I can hit enter to create the boundary fence. Do the same thing here. Do the same thing here. Right? So this process is slightly easier than selecting all the triangles at a time. I can cover more ground with a fewer clicks. All right. So I'm creating boundary fence here, 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 and finally here. Right. So I'm basically creating this closed area. So now if I go to repair and delete, if I choose the boundary fence option, and if I click inside the fence, it's going to start selecting triangles till it's the fence in all the directions. And this is a very nice way to select the triangles. So now if I press the D button, I'm going to delete all of those triangles. So now if I display the box, you can see that it fits pretty well. However, the problem is that the box is much more longer, right? But that's fine. So what I'm going to do is, even in the box, I'm going to go to any. I'm just going to draw a box from right hand side to left hand side. So this way, even if the box is partially selected, all the faces get selected. So I'm selecting all the faces except the top and the bottom face. The bottom face is inside the sphere. So if I hide the sphere, you will see the bottom face, which is not selected. So if I hit delete, the top and the bottom faces are retained. I'm going to draw another box around my bottom face and delete it as well. So now all I have is something like this. And then what I'm going to do is I'm going to go to create a triangle, and I'm just going to loft. I'm going to first select a set of open edges. Make sure that cursor pick option is selected. Select this edge. And for the second set, I'm going to use this particular set. All right. So you can see that it tried to create a set of triangles. But obviously when it tried to loft, you can see that there is also a twist. So if I try to run the diagnosis here, the problem count has definitely gone down. The number of intersections has fallen down quite well. The normal orientation error has increased, but this is not a big deal. I can always transform normal just flip the normal, and then you can see that the normal orientations error typically go away. So intersections are usually harder to clean up, and as you can see that in this particular case we are not getting the right loft. So I'm going to undo this, and the reason why this is happening is you're trying to loft, right? And since you're trying to loft, if the top and the bottom contours are exactly the same, then the loft is going to be perfect. But since the shapes are a bit different, we need to do something called as a directional loft. So I'm going to go to create triangle, and I'm going to use loft directionally. I select open edges, I select this loop first, and then I select this set. Okay, and as far as the direction is concerned, I'm going to say that the align vector is 0, 1, 0. Okay, and let's try to click apply, see what happens. So you can see that now my loft is much better, right? And if I run diagnosis now, I still have normal orientation error, and then repair, I can just flip the normal, and now I have a clean surface. The last thing I need to do is I need to make sure that I go to flag, and then I need to just select the new boundary that I've created, right? So whenever you create a new triangle, all those triangles are added to boundary ID 0. Okay, so originally these triangles were part of the box boundary. So I'm going to now select triangles by boundary. I'm going to select the green triangles, and I'm going to click on the box, and then I'm just going to click apply. Okay, and that is how I would do a cleanup. Now this exercise might seem very simple, but when you're actually doing this, you will learn a lot. You will basically memorize the shortcut keys, how you can switch between vertices, edges, and triangles, and how you can create boundaries, how you can delete it, how to use the loft option, and how to use the loft directionally option. Okay, so this is a great learning exercise. Now based on this, I'll be giving you a challenge, and the challenge is quite simple. You will have different primitive shapes, and all you need to do is join them and come up with a clean surface. I have given a starting file on the leaderboard interface. Use that starting file, and your objective is to clean it up and then assign different boundaries. So I hope in the last 2 videos you learned a little bit about surface cleanup. In the next videos, what we are going to do is we are going to open up a realistic engine geometry, and we are going to clean it up. All right, I'll see you guys in the next video. Bye.